Imagine this. You are a developer and you are tired of the same old keywords in every language. If, print, for. What if you could invent your own completely unique language with keywords no one has ever used before? Well, that's exactly what I did. And the best part? It actually runs real code. Let me show you a quick demo first. Here's a simple program in my language. Run it and look, it works perfectly. So how does this actually work? This is an interpreter just like Python or JavaScript under the hood. Okay, before we dive into the code, let's make sure we're all on the same page. What exactly is an interpreter? And how does it work? An interpreter is a program that takes your code and run it line by line, right then and there, without first turning it into a machine code. Think of it like a live translator at the conference. You speak a sentence, the translator hears it, understands it, translates it, and speaks the translation immediately. The opposite is a compiler. Like C++, Rust, Go, it reads the entire code first, translated everything to machine code, and then you run the compiled file. Now, how does my interpreter work in detail? It follows the classic 4-stage pipeline that almost every interpreter uses. Stage 1. Lexing. The interpreter reads the raw text of your code and break it into small meaningful pieces called tokens. For example, this line of codes become tokens like if identifier age greater than number 18 and so on. It's like splitting a sentence into individual words and symbols. Stage 2. Parsing. It takes those tokens and builds a tree structure, abstract syntax tree or AST. This tree represents the actual meaning and grammar of the code, the relationship between parts. For example, it understands that age greater than 18 is a condition inside a if block. Evaluation or execution. This is where the magic happens. The interpreter walked through the AST with DFS algorithm and actually execute each part. It stores variable in memory, calculates expressions, checks conditions, runs loops, calls prints, and so on. It does all these step by step in order. Stage 4. Output. Finally, it collects everything you ask to print and show it to you. And that's the full cycle, from raw text to running program. The beauty is that this whole process happens instantly. Real languages like Python or JavaScript use much more complex version of this, with optimizations, just-in-time compilation, and huge standard libraries. But the core idea is exactly the same as what I built in just a few hundred lines. Pretty cool, right? Now that you understand how interpreters work, let's jump into the actual code and see how I implement each stage. The whole thing is written in TypeScript and it's only about 400 lines. First, we define all the custom keywords. Here in this section, I created completely unique ones. Echo for printing, when for if statement, otherwise for else, declare for variables, repeat, and through for loops. Next, the lexer function turns the raw code into tokens using regular expressions. Then comes the AST nodes. These are classes that represent different part of the code. Declare for variables, echo for output, when for conditions, repeat for loops, array lists for lists like array 1, 2, 3. The parser is the brain. It takes tokens and builds the AST tree. It handles indentation free blocks just like Python, but with my own rules. Finally, the evaluate function and the main run loop execute everything. It stores variables, checks conditions, run loops over arrays, and prints output. And that's it. A complete custom language under 400 lines. The GitHub link for this project is in the description. If you'd like me to make part 2 where I go line by line and explain exactly what each line of the code does, let me know in the comment. If you enjoyed this deep dive into building a language from scratch, hit that like button, subscribe, and turn on notification. What do you think? Should I add more features like functions, while loops, or math operations? Comment below with your ideas. The most liked one I'll build in the next video.